Hi everyone. In this video we will go over how to create a prediction model with a continuous target. So in this example you see that we have gender, we have age, number of years of education, previous experience, job time, and then a minority, whether you are a minority or not, or the individual is a minority, and the number of siblings, and how all those variables can predict the salary of the individual. So this is kind of a data set that we got from somewhere. So we want to see how powerful or how much those variables can predict the salary. And in this case it is a continuous variable, so it is different from the examples that we did earlier. So one way is to do it using Microsoft Excel. So provides us actually with under data analysis, provides us actually with the ability to run regression analysis, and those are kind of the traditional statistics algorithm that we use for explanation. But so let's run regression first using Microsoft Excel, and then we will use the machine learning algorithm in orange to see. So let's look for multiple or regression, and then I'll click OK. So the Y range will be this column. So all right, so that's my Y, and then for the X it will be all of those, and then Control Shift and the down arrow, so selects everything for me. So I have labels, and then I want it to be in a different sheet. Alright, so now this is a really nice and beautiful regression model for us. So we are interested in looking at the R squared, which is telling us how much percentage all those variables can predict in terms of salary. So they can explain or predict 52% of so the prediction power is 52%. Okay, so they can explain 52% of the variance in the salary. Alright, now let's look at the p-value here, which is in statistics. We look at the p-value, whether the variables were significant or not. So those two are not significant, as well as this one. So basically this tells us those that have p-value of low. So there is a motto that I always use: if the p is low, the null must go. So in other words, if the p is low, then this variable is significant, or is significant in terms of predicting the outcome or the target variable. Okay, so we can say that these variables are not strong predictors, or they don't predict much or at all in terms of salary, and the rest they have some prediction power. All right, so now this is what we find in multiple regression. Now let's use orange and see what we can what it can do for us, and whether it will have similar R squared. So what I will do is I will go to data, and then I'll make sure that I have alright, so I have this data set here, and then I will make sure that I am selecting the employee data. Alright, and then everything looks good to me. This is categorical. Yes, I have 0 and 1, 0 and 1 categorical. And then I'll make sure that my salary is the target variable and apply. Alright, now let's just, for the sake of doing the rank, if we will not actually reduce our features, so we'll just look at them, but we will keep all of them in this case. So let's remove this guy. Now what I will do is I will need to select the machine learning algorithms that are suitable for continuous variables, or for estimates. In this case we call them, rather than classification. So I will use decision tree. I can't use logistic regression, because logistic regression is only for classification. Then linear regression. I can use neural network or random forest and so on. So let's stick to those two machine learning algorithms for now. I'll connect them. and then I will evaluate them. So I'll test and score. So let's look at now how they do. So when we evaluate regression or estimates or when we have target variable that is continuous, we look at the mean squared error. So the mean squared error, so the lower the better. So now we can see that actually linear regression has lower mean squared error, so lower errors in comparison to the decision tree. So we can say linear regression is performing better, so we can stick to the linear regression model, right? So now let's say that we are trying to predict. So to predict, now we will just connect our favorite or the best performing model, in this case is linear regression, and we need to add a data set that we want to test, which is a real, let's say, to be predicted. In this case, it's a new data set. Alright, so now we'll just put it here and see our prediction model, how close it is. So as you can see here, linear regression is predicting to us the salaries for the first record to be 44, 38, and so on for each of those records that we feed it with. So based on the model, the algorithm predicts for us this is what the salary would be. So let's say that we want to also add decision tree, and we will see that also decision tree is also performing, is giving us certain numbers as well. So this is basically how we run regression, or how we run prediction models for estimates using Microsoft Access, Excel, and as well as Orange. So now let's go back here to test and look at the R squared. So our R squared here was 52 or 51 adjusted one, and here our linear regression has 51. So it is very close, very similar to what we had in Excel. So that was all that I wanted to cover. So in your homework, you will need to do something similar to this by cleaning your data set first, and then you can run regression using Microsoft Excel using this one, and then you can run also models in Orange, and then you can submit that. Alright, so that was all that I wanted to cover, and see you later.